All right, good afternoon. I'm going to get started now. So are there any questions before we get started? There are a few things I want to talk about before I leave it to you to ask questions. So let me go through this first, and I'll make sure you have enough time to ask any questions you have about the exam that's coming up. All right, so if you remember at the end of last class on Wednesday, we talked about, well, let me see, so recall, we had a few equations that was product to some equation formulas. I'm not going to write down all of them, I'm going to write down one. So one of them was sine, I forget I used alpha of A. So let me quickly double check with alpha. I used sine alpha. So recall we had sine alpha, sine beta, and that's equal to 1/2 cosine alpha minus beta minus cosine alpha plus beta, or A plus B. I forget exactly what I used. So that's the product to sum formula. Now, in this formula, suppose we manipulate the terms here. So suppose we're going to let alpha equals u plus v over 2, where u and the v are two angles, and the beta is equal to u minus v over 2. And if we substitute into that equation above, so alpha minus beta, that's going to equal to u plus v over 2 minus u minus v over 2. And if we are careful here, that's going to be u plus v minus u minus v in a parentheses. And when we distribute the negative, the u term will cancel, but we have 2v. We get 2v over 2, which is v. So that's alpha minus beta. And the alpha plus beta is going to be u plus v over 2 plus u minus v over 2. Again, if we follow the same trick, we eventually end up with u plus v plus u minus v over 2. That's equal to 2u over 2, which is u. So with u and the v and alpha and the beta, we can rewrite the equation above. So we have sine alpha on the left. So sine alpha becomes sine u plus v over 2 times sine beta, which is sine u minus v over 2. That's going to equal to, what did I write? One half cosine alpha minus beta, that's a v, minus cosine alpha plus beta, that's u. So now if I rewrite this again, so I'm going to multiply by 2 on both sides. And I'm going to switch the sides. So now I have cosine v minus cosine u equals 2 times sine parentheses u plus v over 2 and the sine u minus v over 2. Now, normally we like to put u before v. So if I rewrite the left-hand side, I get by switch the order or multiply by -1 on both sides. So let's see, we multiply by -1 on both sides. So I have cosine u minus cosine v, which is equal to -2 sine u plus v over 2 and sine u minus v over 2. So I end up with this new formula, which converts a difference, or sometimes a sum, into a product. So this is called sum to product formula. kind of like the product to sum formula. This is sum to product formula. Just allow us to write down a product in terms instead of a sum or a difference. Sometimes that might be handy if we want to simplify some terms. Right. So this is one of them. And remember the 4 of the previous product to sum formulas, right? So that means there's going to be 3 new formulas from sum to product. So let me just copy them down again. I don't really require you to memorize it, and there's really no need to. But I just want to write them down so you can see them. So this is a cosine u minus cosine v. The next one is cosine u plus cosine v. And that's equal to 2 cosine u plus v over 2 times cosine u minus v over 2. And then we have sine. So sine u plus sine v. So that's going to equal to 2 sine u plus v over 2 cosine u minus v over 2. And then similarly, we have sine u minus sine v, which is equal to 2 sine u minus v over 2, and the cosine u plus v over 2. So those 4 are the sum or difference to product formula. We just call it sum to product formula because the difference itself is the sum of the negative. All right. So for us, we just need to know how to use it and to see how much difference it's going to make when we apply it. So for example, so we can write sine 4 theta minus sine 2 theta as a product. So that's the difference between 2 sine. So we're just going to use the last one, the one directly above this exercise. So we get sine 4 theta minus sine 2 theta. And the 4 theta is equivalent to u. And the 2 theta is equivalent to v. So that's going to equal to 2 times sine. Inside, we have the numerator u minus v. So that's 4 theta minus 2 theta all over 2. And the cosine, the product, 4 theta plus 2 theta all over 2. And we can simplify this as 2 times sine. 4 theta minus 2 theta, that's the 2 theta. So that's the 2 theta over 2. Cosine is going to give us 6 theta over 2. And then we divide by 2 in the parentheses. So we get 2 sine theta cosine 3 theta. And you probably feel like, oh, what's the whole point of doing this, right? Clearly, it's just a different way of writing the expression. And if for some cases, we probably prefer this form, but maybe there are other cases we prefer the subtraction. So again, it's this way, this formula just allow us to convert one form to the other one. So the next example I have is evaluate cosine 15 degrees minus cosine 75 degrees. So suppose we didn't know this formula at all. Suppose we just remember the sum of angles formula and the difference of angles formula from a while ago. We can rewrite this as, so the 15, we can think about that cosine 45 degrees minus 30 degrees. And the 75 degrees we can think about is 45 degrees plus 30 degrees. And from there, we can use the difference of angles formula and the sum of angles formula to work with each one there. And at the end, we should be able to find the difference. That's one way. Now, we can also use the new formula we had, which is says if we have a difference of two cosine, we can convert it into a product of two sines, the first one. So let's try this second approach. So method two. Cosine 15 degrees minus cosine 75 degrees. So this is my u, this is a v. And that's equal to -2 sine u plus v, so 15 degrees plus 70 degrees, 75 degrees all over 2, and the times sine u minus v, so 15 degrees minus 75 degrees all over 2. And then that becomes -2 sine of 15 plus 75, that's 90 over 2, that's 45 degrees, times sine of 15 minus 75, that's -60 over 2, so -30 degrees. As you can see at this point, we all know what sine 45 degrees is. So that's a -2 times √2 over 2. And the sine 30 degrees, so if you recall the negative angle formula, so that's a sine -x equals negative sine x. So this second part becomes negative sine 30 degrees. Again, we know what sine 30 degrees is, just half. So we get -2 times √2 over 2 times -half. And eventually that's a lot easier in this case. So we get √2 over 8. Sorry, √2 over 2 because the 2's cancel. So √2 over 2. And negative become positive. So it's a lot. Some people think this is a lot faster to solve. But again, you do have, if you want to apply it quickly and efficiently, you do have to memorize it, memorize the formulas. But suppose you don't, you can always look it up on the internet. I just want to use this example to show you that this formula could make things slightly easier. Any questions? All right, let's do one more example of this type. So we want to prove whether the following equation is true or whether we want to show it's not true. But anyway, I think it's true, but still we need to carefully prove it. So cosine 4t minus cosine 2t divided by sine 4t plus sine 2t, and that's equal to tangent t. So we need to prove that's true. So which means we cannot cross multiply. We just have to take a side, work with it. And it looks like there's a lot we can do with the left side. So let's say left-hand side equals the numerator. I'm going to use the difference of the difference to product formula. So that's going to be negative. So we have cosine minus cosine, just like the one above. So that becomes 2 sine. This will be my u. This is the v. So sine u plus v over 2. So 4t plus 2t over 2 times sine u minus v, 4t minus 2t over 2. And all over for the sine part. So we get sine plus sine. Again, I'm going to go back to the formula, use this one to rewrite it. So that's 2 sine u plus v. In this part, we have this is the u, that's a v. So we get 4t plus 2t over 2. And then we have cosine difference, so 4t minus 2t over 2. So that's the left-hand side, and then we can try to simplify this. And by inspection, oh, I forgot that's a negative. I'm wondering why that doesn't make sense. So this is a negative tangent we need to prove. By inspection, we can tell that the 2 and the 2 cancel, the big sine term cancels. We don't even have to calculate 4t plus 2t over 2 because they look identical from numerator and denominator. And we just have the sine and the cosine remaining. So let's simplify this. So that becomes negative sine 4t minus 2t, that's 2t, divided by 2, which is t. And divided by cosine, again, 4t minus 2t is 2t, divided by 2 is t. So we get negative sine t over cosine t, which is negative tangent t. That's equal to right-hand side. Earlier, I wrote down incorrect right-hand side, forget the negative. The negative one should be there. So that's the difference to product or sum to product formulas. Any questions on those? All right, so I'm going to stop there. Again, there's other stuff I need to talk about, but I want to stop here and give you opportunity to ask questions about the exam, because anything we talk about until this point could be on the exam. But I just want to go back to what we talked about yesterday. So there was a few formulas I highlighted that you have to memorize. You have to know, for example, obviously you have to know the sine negative x formula and the cosine negative x. And you have to know the sine double angle formula, cosine double angle formula, right? And you also need to know the sum and the difference of angle formula. Let's see, is there anything else? You have to know trig identity, like sine squared theta plus cosine squared theta equals 1. And it would be nice if you know 1 plus tangent squared theta equals secant squared theta. But those you have to know very well. If you don't know them, a lot of times it's difficult to solve equations, to simplify, or to prove identities. And obviously you have to know the definition for like secant, cosecant, theta, secant, theta, and also cotangent, right? That's just the reciprocal of sine and cosine and the tangent. You have to know them. You also should know that tangent theta is equal to sine over cosine. It's nothing new. I'm sure you all know it by now, but it's just something that you should know. And other formulas, it's okay if you don't know them, memorize them. That's totally fine, because there are a lot of formulas like the half angle formula, the reduction formula. I personally don't think there's any need of memorizing that. Suppose you have a problem like this on the exam. I will definitely keep in mind to provide them for you if you need it. But other than that, I think given any problems you have, you should be able to just use whatever we have over here to solve it. You can always convert everything back to sine and cosine to solve anything. All right, so make sure you know them really well. Any questions? All right, any questions about the exam or, from reviewing for the exam, anything? All right, I know this is the last exam. Definitely do your best because after this exam, we only have, there's a homework assignment due Sunday and also another homework assignment due Friday. That will be it. And yeah, just make sure you do it and do well. All right. So, well, think about it. If you have any questions, you can always ask in a bit. We're going to have time towards the end to go over anything you might have. But if you have any questions, definitely let me know.
Do you have office hours tomorrow or Monday in case I think of anything, or?
Yeah, I do have office hours tomorrow and a Monday. If I'm not there, definitely send me an email, and I'll be there.
All right, cool.
Yep, no problem. Anything else? So what I'm going to talk about next is not going to be on the exam, but it's going to be on the following homework, not on the following. Is not Monday's exam. All right, but doesn't mean that you shouldn't know them. You should still pay attention so that you can do well on the homework, and the next class you take, it's probably going to require the information anyway. So the next thing I'm going to do is I'm going to talk about solving trig equations. So we're going to solve equations such as, I'm just going to go through a few examples because it's better to go through examples than conceptually talk about this section. So find all possible solutions for the equation cosine theta equals 1/2. So that's it. The equation is cosine theta equals half. Simple. But the question is not just to, okay, what is theta, right? It's actually asked us to find all the possible solutions. So if you want, you can just take inverse cosine on both sides. So theta equals inverse cosine of half. And by definition of inverse cosine, you're only going to get one value. So by definition, the theta we get is only going to be in the top half of the circle from 0 to pi. Because that's the definition of inverse cosine. Well, let's find out what it is. So we know that cosine theta equals half, so that means whatever point on the unit circle. So this means that the x coordinate equals 1/2. So x is half, so that corresponding to this point here and this point. But by definition of inverse cosine, we can only use this one above the first one in the first quadrant. So how big is the angle? Well, using the x coordinate equals half, by drawing the angle, looks like that angle is more than 45 degrees. I'm just eyeballing it. Either going to be 30, 45, or 60, right? So it looks like it's going to be 60 to me. It definitely doesn't look like 30. So that means the angle theta is equal to 30 degrees or pi over 6. Sorry, pi over, no, I don't know what I'm saying, 30. So the angle is 60 degrees or pi over 3. So that's how big theta is by using the definition of inverse cosine. But that clearly is not the only angle that's going to have a cosine equals half. And we already see it. There's also a second angle in the fourth quadrant, this one, corresponding to the same cosine value because it has the same x coordinate. So this angle in the fourth quadrant is going to be a negative. It's going to be a reflection. So that's going to be negative 60 degrees or negative pi over 3. So that's also a valid angle. So we get 2 plus theta equals pi over 3 or negative pi over 3. Both work. The question is, are there other angles that will give us the same cosine equals half? Well, there are, because if we take, let's just say we take an angle and then we go around the full circle once and then go back up to this pi over 3 terminal. So that's a coterminal angle to pi over 3. It's going to have the same cosine. suppose I did not stop there. Suppose I go from the same place, go a full circle, and another one, and then come back to the same place. So suppose we have was my terminal site, and I'm starting on the x-axis, going a full circle, and another full circle, and go back there. That's also the same cosine value. We could do the same thing to the negative pi over 3 by just adding 2 pi each time, a full circle each time. We always end up with the same terminal side, and that's going to give us the same cosine value. So in order to find all the possible solutions, what we do is we just find the 2 on the circle, and then we're just going to add multiples of 2 pi. So theta equals pi over 3 plus 2 pi times k, or negative pi over 3 plus 2 pi times k, where k is the integer, so I'm going to use z. So k belongs to the set z integers. So that's actually the solution that's going to give us all of the possible solutions for the angle theta. So it's not just one angle, pi over 3, using the definition of inverse. It's actually asking us to find all of the angles. Any questions on this? So whenever you're asked to find all possible solutions, means at some point, you're going to add 2 pi k, or maybe pi k if it's tangent. But sine, cosine, we add 2 pi k. All right, the second example I have is we're going to solve 2 sine x plus 1 equals 0 for x is inside the interval 0 to 2 pi. So here it's not looking for all x values. It's only for x value that's from 0 to 2 pi. So we're going to solve the equations we normally do to find x. So we minus 1 on both sides and divide by 2. So we get 2 sine x equals -1 divided by 2 on both sides. We get sine x equals -1/2. And if we rewrite it using inverse sine notation, we get x equals inverse sine of -1/2. Again, if we use the definition of inverse sine, we can only find one angle in the right half of the circle. So whatever the angle we find using the definition of inverse sine, it's only going to be in the first or fourth quadrant. So let's think about this. So we have sine x equals -1/2. So that means the y coordinate equals -1/2. So we're going to go to the y axis and find the -1/2. And then we're just going to draw a dotted line horizontally. So that's going to give us this angle in the fourth quadrant that fits into the definition of inverse sine. And then just by looking at it, it's not going to be 45 degrees. This angle looks like it's going to be -30 degrees, or -pi over 6, right? It just does not look like it's going to pass 45 degrees. Okay, so that's just using the definition, but it looks like there's another angle on the left side of the x-axis is going to give us the same y coordinate, the same sine value. Now this angle on the left is going to be this angle. How big is it? You can either use positive angle or negative angle. It's up to you. Suppose I'm going to use positive angle. So how big is this angle? That's from here to there. That's pi. And it looks like it's like passing the pi by 30 degrees, or pi over 6. So that's the 6 pi over pi. This must be 6 pi over 6. That's pi. This must be 7 pi over 6. Or it's going to be 210 degrees, 180 degrees plus 30 degrees. So we found two angles here. And the question asking us to find all the angles for axis from 0 to 2 pi. I know we found one that's in the third quadrant, another one in the fourth quadrant. Looks like that's all the angles. It's going to have this -½ as a y coordinate. We're not going to have angles in the first and the second quadrant because that in those quadrants the y's are positive. So there we have two values. X is equal to -π/6 or 7 pi over 6. But we have to be careful. We want the axis from 0 to 2 pi. So the -π/6 is not in the interval given. So we have to rewrite this using the positive angle. So -π/6 is the same thing as 11 pi over 6. So that will be the correct form to write the answer. Even though -π/6 does give us the angle in the fourth quadrant, but it's not in the correct interval. I just want to point out that you could just think about, we have a -π/6, but we want the angle to be from 0 to 2 pi. So that means we're going to add 2 pi to -π/6. Now it becomes positive. We can actually use the positive angle. Any questions on this example? All right. So the next example we have is to solve this equation, 2 sine squared theta -1 equals 0. And for theta is from 0 to 2 pi, including 0, but does not include 2 pi. So by looking at it, if we want to find theta, we have to isolate sine squared theta first. So +1 on both sides, and we're going to divide by 2. So we get 2 sine squared theta equals 1 divided by 2. So we get sine squared theta equals 1/2. Now we have a square equals 1/2. We have to take square root. So sine theta equals, when we take a square root, we have to add plus minus square root of 1/2. And if you remember, square root of 1/2 is the same thing as √2/2. So we get plus or minus √2/2. So sine could be positive or negative, but which one is it? We don't know. Could be both. So we're going to write down two equations from here. We get sine theta equals positive √2/2, or we get sine theta equals negative √2/2. Okay, so what is the angle of theta? Now, this one, you can, again, try to use the unit circle if you want. So we get sine is √2/2. So that's a half. This is a 1. So √2/2 is about halfway. It's a little bit more than half, halfway between half and a 1. So that's going to give us this y coordinate and this one. So we get 2. So that's going to tell me that theta is equal to, I mean, you probably memorize it, pi/2. Sorry, √2/2 corresponding to angle pi/4. So theta equals pi/4 or 3 pi/4 from the first equation. Now, what about sine theta equals negative √2/2? So the y is going to be negative. So this is a -1, -½ negative √2/2 is about here. And if we draw the angles, we get, again, you can use positive angle or negative angle, it's up to you. But I'm going to keep them as positive. So this angle is going to be pi. This must be 5 pi/4. And 6 pi/4, 7 pi/4. So those are the 4 angles that's going to give us sine theta that's satisfying the equation above. And suppose you just take the negative pi over 4 and the negative, sorry, that's not 3 pi over 2, 3 pi over 4. Suppose you had pi over 4 and a 3 pi over 4. That's negative. So negative pi over 4, all you have to do is add 2 pi to make it positive. So in this case, we get 4 angles satisfying the equation. Right. So now let's look at another example. Any questions on those equations so far? All right. So the next example I have, we're going to solve secant theta equals -2 for theta that's from 0 to 4 pi. 0 to 4 pi is that 0 to pi, that's a full circle, and then you just go around another circle, that's 0 to 4 pi. So we have secant theta equals -2. How do we solve for theta? Well, I don't like secant, so I'm going to rewrite it using sine or cosine. In this case, it'll be cosine. So that means 1 over cosine theta equals -2, and I'm going to flip both sides. So I got cosine theta equals -1/2. Cosine is the x value. So x equals -1/2. Let me erase this on a unit circle. X is -1/2. So it must correspond to those 2 angles. And then the angle in the second quadrant looks like it is 120 degrees because its reference angle is about 60 degrees. Same thing here, 60 degrees. So the angle in the second quadrant, so that's going to be 120 degrees. So that's 2 pi over 3. So we get theta equals 2 pi over 3. That's the first one, 2 pi over 3. And then 3 pi over 3, that's a pi, and then 4 pi over 3 is the one below. So we found 2 angles in the circle from 0 to 2 pi. But here we're looking for all the angle from 0 to 4 pi. So that means we have to go around the circle one more time. When we go around the circle one more time, the 2 pi over 3 is going to be 2 pi over 3 plus 2 pi. So 2 pi over 3 plus 2 pi, that's going to be a good angle in the 0 to 4 pi range. And the same thing with 4 pi over 3. We're still going to add 2 pi to it. So in this specific example, we get 4 angles satisfying the equation. Now you probably wonder, why don't we keep adding 2 pi? Well, if we add another 2 pi, so 2 pi over 3, I'm going to erase this in a second, plus 2 pi, and if we add another 2 pi, that's going to be more than 4 pi. It's not going to be in the interval anymore. So we don't take those. Any questions on this? All right, if not, I'm going to go. So again, problem like this, you probably know how to solve it. The algebraic part probably not too complicated, but you have to be careful where the angle belongs to. What's the interval that I'm looking at? So the next example I have is solving cosine 2 theta is equal to 1/2. We had a problem similar to this. We had cosine theta equals half in the past. For theta, that's from 0 to 2 pi. So the difference is here we have cosine 2 theta. So how do we solve this? Well, the way I solve it is first I look at, okay, I know that theta is from 0 to 2 pi, but when I add inverse cosine, I get 2 theta is equal to inverse cosine of 1/2. So I end up solving for 2 theta first and then solve for theta, right? So if I know that theta is from 0 to 2 pi, what about 2 theta? That must be from, if we multiply everything by 2, so 2 theta must be from 0 to 4 pi. So that would be an important condition to keep in mind. Okay, so let's find it. So on the unit circle, cosine is equal to 1/2. So that's going to give us those two angles, pi over 3. And this one we said is going to be negative pi over 3, but we want to keep it positive. So when we add the 2 pi, it becomes pi over 3 to 2 pi over 3, 3 pi over 3, 4, 5. So that's a 5 pi over 3 coterminal. So we're going to take the angle 2 theta is equal to pi over 3 or 5 pi over 3. So those are the two angles within the 0 to 2 pi range. But I don't want just for 2 theta to be from 0 to 2 pi. I want 2 theta to be from 0 to 4 pi. I have to add each angle there with 2 pi, a full circle. So now I have 4 angles. That's going to give us 2 theta. And each of the angles is going to be from 0 to 4 pi. So I'm considering all the options for 2 theta first, from 0 to 4 pi. And then the next step is to find theta. All we have to do is take each of the angle and divide by 2. So theta equals pi over 6 or 5 pi over 6. Or if we take pi over 3 plus 2 pi divided by 2, so that's going to be, so that's pi over 6 plus pi, or 5 pi over 6 plus pi. So those are the 4 angles, and it's just to make things look nicer. It's going to simplify the last two. So I get pi over 6 or 5 pi over 6, and then pi over 6 plus pi. So that's a pi over 6 plus 6 pi over 6. So that's a 7 pi over 6 or 11 pi over 6. We get 4 angles. And in this case, we get 4 because remember, theta is from 0 to 2 pi, but 2 theta, that's from 0 to 4 pi. We have to find all the angles for 2 theta first. Any questions on that? All right, let's do one more example similar to this one. The next example, what we're going to do is we're going to solve tangent theta minus pi over 2 equals 1. Now, we all know what tangent of 1 is. The tangent of what angle gives us 1, right? Tangent of 45 degrees gives us 1. That's what we memorized in the past. But here we're looking for tangent of theta minus pi over 2 give us 1. The first thing, let me write down. So theta we want is going to be from 0 to 2 pi. So that's for angle theta, but when I solve for theta, I'm first going to solve for theta minus pi over 2. So I need to know the range for theta minus pi over 2. So subtract pi over 2 from all terms. So I get negative pi over 2 is between, is less than or equal to theta minus pi over 2 is less than 2 pi minus pi over 2. That's a 3 pi over 2. And now I'm going to take inverse 10 on both sides to my original problem. So theta minus pi over 2 equals inverse 10 of 1. And if you are familiar with unit circle, or based on what you memorized, you know that tangent of 45 degrees is equal to 1, because that's the ratio between y and x. And similarly, if you extend this into the third quadrant, you get another angle. So we get those two angles. Basically, we draw the line y equals to x through the origin. And wherever the line touches the circle, that's where the angle should be. So this is pi over 4. This one is going to be negative. I'm going to keep it positive. So that's going to be positive 5 pi over 4. Those are the two angles that's going to give us inverse 10 equals 1. But we want to find the angle that's from negative pi over 2 all the way to 3 pi over 2. Are there any angles that we have not covered yet? No, right? Those are the only two correct angles. So we get theta minus pi over 2, that's equal to pi over 4, or theta minus pi over 2 equals 5 pi over 4. So that's theta minus pi over 2, but we want to solve for theta, so we're going to add pi over 2 to both sides. So we get theta equals pi over 2 plus pi over 4. And that's going to give us 3 pi over 4 here. Or we can have theta equals pi over 2 plus 5 pi over 4. And that's going to be 7 pi over 4. So in the end, we get those two angles for theta. All right, are there any questions on those examples? All right, I am keeping an eye on the clock, so we are fine. I'm almost, well, I wouldn't say I'm almost done. I'm sort of getting close toward the end of what I need to cover. So if you have any questions, just prepare them, and then you can ask them in a few minutes. All right, so let's see. We're going to solve this. So solve this equation. 2 sine squared theta minus 5 sine theta plus 3 equals 0. And we want to find theta. That's going to be from 0 to 2 pi. Now, if you look at it, you know, this should be something familiar, right? It's like a 2 times something squared minus 5 times something plus a constant equals 0. That's exactly what quadratic equations look like. But here, instead of having x there, we have sine theta. So what we can do is we can use substitution. So substitute for sine theta with x. So we're going to say let x equals sine theta. And then the 2 sine squared theta becomes 2x squared minus 5 sine theta becomes 5x plus 3 equals 0. Now we have a quadratic equation, should be easy to solve. It's always a good idea to try to factor this. So we get 2x and x. Now we want to put two numbers that multiply give us 3. But when we put two numbers into the parentheses, when we expand it, we're going to end up with negative x. So it looks like we're going to have -3 and a -1. And suppose factoring doesn't work for you in this case, you can always use a quadratic formula to find x. So that's equal to 0. And then we can solve each quantity. So we get 2x minus 3 equals 0, or x minus 1 equals 0. So we get x equals 3 halves, or x equals 1. So we get 2x values. Now, if you go back to the problem, remember x equals sine theta. So that means sine theta equals 3 halves, or sine theta equals 1. And we just have to find theta from here. Now you probably think, okay, there are two equations. That means we're going to have a lot of answers, which usually is true, but not always true. Like for example, in this case, the first equation, we have sine theta equals 3 halves. And if you remember sine function or the unit circles, the biggest sine value is 1, the smallest sine value is -1. You're not going to have any value above 1. So that means sine theta equals 3 halves. That's not going to give us a solution. So recall sine x is always going to be from 1 and a -1. So no solution here. Because 3 halves is beyond this interval of y values. What about the second equation? We get sine theta equals 1. Well, that's possible. What is the angle then? Well, this is the only place where we're going to have an angle with a sine that's a 1. And what is the angle? The angle is pi over 2. Is there any other angle from 0 to 2 pi going to end up here? No, so we only have one answer. So theta equals pi over 2. All right, any questions on this? All right, I have two examples. I'm thinking if I should combine them. Sure, it doesn't make a difference. How does it? You know what? Let me take a couple of steps. We're still good on time. So let me just go through them separately. So we have the next example is to solve 2 cosine squared theta plus cosine theta equals 0 for theta that's from 0 to 2 pi. Okay, so how do we solve this? It looks like it's a quadratic again. So if you want, you can substitution. So we can say, okay, we're going to let x equals cosine theta in this case. We get 2x squared plus x equals 0. And then we can factor out x. We get x times 2x plus 1 equals 0. Solve them separately. So we get x could equal to 0, or maybe 2x plus 1 could equal to 0. The second equation tells us that x equals -half. But remember, x equals cosine in this problem. So that means cosine theta equals 0, or cosine theta equals -half. All right, so what's the angle? So let me draw a unit circle here. Cosine theta equals 0, so x value equals 0. So that's going to give us those two angles. Pi over 2. And then this is 3 pi over 2. So theta equals pi over 2 and 3 pi over 2. So that's from the first equation, cosine theta equals 0. From the second equation, we have cosine theta equals -half. So -half is here. If we draw the -half x coordinate, and it's going to give us two angles. The first one is here. That's about 120 degrees, which is 2 pi over 3. And then we have pi plus pi over 3. So that's a full pi over 3 in the third quadrant. So you can always think about, okay, so that's about 60 degrees. So this is going to be 180 minus 60 degrees. And then the reflection is going to be 180 plus 60, which is 240 and 120. So for this specific problem, we get 4 angles. All right, any questions on those? All right, then. If you don't have questions, let me go through another example again. So this example and the previous one, they're kind of like giving you some expression, looks like a quadratic equation. If you use substitution to convert it into quadratic equation with x, we can solve for x. But remember, we're looking for theta at the end, right? So you have to go back and then find theta at the end. The next example I have is solve cosine 2 theta equals cosine theta. And for theta, that's again from 0 to 2 pi. We're just going to keep the standard interval here. Okay, so how do we solve this? We got cosine 2 theta on one side, and then we got cosine theta on the other side. Now, they're not, even though they said cosine, but they're different because one is theta, one is 2 theta. You have to think about them as different variables. So treat those two as different variables. It's kind of like if you have x on one side, but then instead of x squared, you actually have maybe y on the side. They're different, they're not the same. So in order to solve the equation, find the exact solution, we have to somehow rewrite one of the terms in terms of the other one. So we're going to rewrite cosine 2 theta in terms of cosine theta. So that's going to be, if you remember cosine 2 theta in terms of cosine theta, that's going to be 2 cosine squared theta minus 1. That's equal to cosine theta. So now we have cosine theta, cosine square theta. They're the same, they're not different. And from here, we're going to try to use substitution again. So we're going to let x equals cosine theta. So we get 2x squared minus 1 equals x. Move everything to the same side. So we get 2x squared minus x minus 1 equals 0. We can try to factor this, just like the previous example earlier. So we get 2x and then x. And we need two numbers when we multiply, give us -1. So either going to be 1 or -1. So then you just have to try where to put which one. You can try to put -1 here, +1 here, and then notice that it's not going to work because that's going to give us +2x minus x. But we're going to flip them. So +1 in the first parentheses, -1 in the second one. Now it works. So that's equal to 0. This is going to tell us 2x plus 1 equals 0, or x minus 1 equals 0. So we get x equals -half, or x equals 1. But remember, we are not looking for x, right? We're looking for angle theta when we solve the equation. So we have to rewrite x with cosine theta equals -half, cosine theta equals 1. And then from here, we should be able to solve for theta. So let me again draw the unit circle. cosine is the x coordinate, x value is -half. So that's a -half. That's going to give me this two angles. We already had them a while ago. Well, not really a while ago, like maybe a few seconds ago, right? So the theta here, right here, we had them. It's going to be 2 pi over 3 or 4 pi over 3. That's those two angles. And what about cosine theta equals 1? So we're looking for x coordinate is 1. So x equals 1 is right there. Sorry, that's not 1. I'm looking at the wrong side. Cosine theta equals 1. So we're looking for x coordinate equals 1 right there. The other side is negative. I got confused. So that's 1. And how big is the angle? Remember the angle I'm looking for is from 0 to 2 pi, including 0, but does not include 2 pi. So it looks like the only angle we have is going to be 0. Because we're not including 2 pi. So those are the three angles we have that will satisfy the equation above. All right, any questions on those examples? Okay, like I said, the solving the equations, they're not going to be on the exam, but it will be on the next homework next week. And we're not going to have a quiz or anything on this material, but you should learn them. You should pay attention because it's important to know them well. All right. Any other questions? Well, let's go back to the exam. Any questions related to the exam? It's only going to cover the material from the second exam to now. Just think about it as a big quiz. It's not really an exam. Any questions? All right, last call. Any questions? I know I post the homework rather late, so you probably don't even have a chance to look at the homework problems. But when you do, if you have any questions on the homework, let me know. All right, then on that note, if you don't have any questions about the exam or about the class today or anything in general, I'm going to let you go. So before I let you go, on Monday, the exam 3 is going to be just like the exam 1 and 2. I'm going to make it available for you. Again, you don't need to show up to the Zoom meeting. If you have any questions, I'll have the Zoom available. You don't need to be there before the exam, and the exam is going to be available at 6:10 like before. Okay, then on that note, no questions, and I'll see you. Well, I'll probably not see you on Monday, but I'll see you on Wednesday. All right, take care, everyone. Good luck and have a good weekend.
Thank you. Have a good night.
you.
Okay, bye-bye. Take care.